Good morning, everyone. My name is Timothy Lee Grant, and today I want to talk about the advantages and disadvantages of the electrical engineering major. So, I am currently a senior electrical engineering major at Oregon State University. So, I think I have a pretty good idea of a lot of the problems and a lot of the really cool things about electrical engineering, and I wanted to share those with you. So the first point that I have is that electrical engineering is extremely broad, and when I say broad, I mean very broad. A lot of the different subjects that are covered by electrical engineering don't actually connect with each other. So for example, you can go into like power. So for example, hydroelectric power, if you want to work on that, is solar power, wind farms, right? And how you distribute that power, how you get that power from the production plant to the actual homes. That's one specialization. Then you can go into stuff like hardware, for example. You can figure out circuits and try to figure out like how to create logic gates through all of these circuits. Then you can also do stuff in the semiconductor world. You can go more of the CS route. So that's kind of what I'm doing. Is my degree is actually called electrical and computer engineering. So that's the way that Oregon State does it, is that the electrical engineering also has a computer engineering section to it, so you get an even more broad base. So I'm really interested in like the software and CS kind of side of things. I'm not as big a fan of actually like building hardware and testing circuits and stuff like that, but I absolutely love to be able to sit at a computer, just like debug code, try to figure out what's going on, and just do these incredibly interesting like algorithms that you can see real time and fix real time. I really like the CS side, so that's kind of what I'm going into. Another aspect that I'm really interested in is physics. So I'm going to be taking guided wave photonics, lasers and applications, and one other class, all regarding like optics. Oh, that was it. It was called optical electronics. So all of those classes are physics-based classes. So as you can see, like electrical engineering, you can pick and choose which subfield you want to do. And it's really good because for the first 2 years, you're doing your basic like mathematics and just your circuit analysis and your really basic level classes that get you prepared for your junior year and then your senior year. Then what happens during your junior year is you get an introduction to all of these little subfields. So you do transmission lines, then you do signal analysis, then you do like data structures and algorithms, and you do what were some of the other classes? Electronics 1 and 2, right? Like you get an introduction to all of these little subfields, and then senior year is when you get to decide, okay, now I have a wide array of classes that I really enjoy. Which one do I want to choose, right? And so for me, I got this experience and I said, wow, okay, I really enjoyed my CS classes and my physics classes. So now I'm going to go into that specialization, and I'm not as passionate about the hardware or the power, like how to generate power, how to distribute power, etc. So it gives you a lot of time to be able to figure out what exactly you're really passionate about and what you want to go into the future. And so then if you want to get a master's degree, it's really easy to go into that specific field. I was talking with some of my professors and I asked them like, hey, so I have a question. Like if I wanted to go into computer science for my master's degree, what, as an electrical engineer, am I hindered by this? And the professor, who is a computer science professor, by the way, not electrical engineering, they said, oh yeah, that's absolutely no problem. And in fact, because you have a background in electrical engineering, especially if you go into something like machine learning, you're going to have a fairly big advantage over some of the computer science based people because you know a little bit more on the signal processing side. So this is a huge advantage to electrical engineering because you're able to figure out what you want. Alright, so the next point that I have is that with electrical engineering, it's really good if you are kind of like a hobbyist. Like you really want to build some stuff. So you're going to be learning about how to communicate between different devices, right? So you're going to be taking specifically a hardware-based class. This one is assembly. And you're going to be learning about how to toggle or how to send data back and forth through ports. You're going to be learning about the baud rate, how the clocks work, all of this. And so if you're trying to communicate with something else, if you're building something and you're trying to communicate between two different devices, you're going to be able to have a much better understanding about what's going on. In addition, anything that needs power. So if you're doing any project that needs power, this background is going to be extremely helpful because you're going to know about how to not cause a short circuit. You're going to learn about how to ensure that you have enough resistance to account for the voltage, and so you're going to be able to do hobbyist projects more than almost any other degree. Mechanical engineering, you're going to be building devices, right? And you're going to be like measuring the stress on the device and how much pressure it can take and stuff like that. But you're not going to be building a robot. You're not going to be able to do anything that requires power. Electrical engineering is completely different because you can build those robots. You can do these hobbyist skills, and you have the computer science background for programming required for Arduino, Raspberry Pi, anything that requires computer science and programming. And then you're also going to have the hardware understanding to be able to put it into use into a physical device. So that's two of the biggest advantages that I see for electrical engineering. So now back to the disadvantages. And I mentioned that electrical engineering is extremely broad. I put this as an advantage, but it's also a fairly large disadvantage. And the reason for that is because, as I said, each of those different subfields don't actually connect together, so you don't really get a very deep understanding of each of the subjects. And this causes a lot of problems. One of them is imposter syndrome, because if you come to me and you're like, hey, I want to learn about, or tell me about transmission lines, right? You're an electrical engineer, tell me about transmission lines. I'm going to be like, well, okay, I know how to use a Smith chart. I know the basic concepts of, like, if you're sending a signal down a wire, it doesn't travel instantaneously. If it goes through a different medium, it's going to cause a reflection. Then those reflections are going to cause all sorts of problems. So I know the basic concepts, but I don't know a lot about it. If you ask me about signal processing, okay, well, I know how to take a signal in the time domain, put it over into the S domain, and then I know the basic mathematical operations that are acceptable in the S domain, and then I know how to do an inverse Laplacian transform and get it back into the time domain, right? But I don't actually know how to apply it. To be completely honest, I don't know how to use that and make it useful. I just know the very surface level, and so it can be frustrating at times because you're learning so many different individual skill sets, and it feels like you're not actually learning anything. You feel like you can't apply anything, and that can be very frustrating. It was extremely frustrating for me, but I think the idea behind this is that the schools want you to get a very broad understanding of many different topics, and then once you're in your job, then what you can do is, if your job needs you to do signal analysis, for example, you have the base understanding to move forward. So you know where to start, You know which concepts you need to learn more about. You know which resources to use, and then you can advance and learn by yourself whatever concepts that come up in your job, because you're not going to be able to teach an electrical engineer everything that they need for their job. So you want to be able to give them an ability to be able to move forward and be able to learn anything that they need while they're on their job. The other thing that having a broad degree causes is that you're going to have to learn subjects that you don't actually care about. So, for example, as I said, I don't have much of a passion for power and how to distribute that power, but I still have to take classes on it, right? And other people might not have a passion about what I like, which is more computer science and signal processing and all of that, but you're still going to have to take a class on it. So that can be a disadvantage, and I've talked with a few of my friends, and they said, yeah, it sucks that I have to learn this. I don't care about it. And so it can, like, weigh on people. The final disadvantage that I see with electrical engineering is that it's difficult. It's very math intensive, in specific multivariable vector calculus and Laplace transforms and stuff like that. So if you don't like math, try to learn to love it. I don't know, like, just that's kind of what I did, is I just forced myself to like math, and now I kind of like it. You're not going to have to be using you're not going to have to do any proofs. This is the way I can put it. You're not going to have to do any proofs. You're not going to have to do any of those weird math. As long as you have a good understanding of calculus, you're going to be fine. In engineering, math is a tool, so calculus is extremely useful, and it helps you solve all of these complex problems. So if you have a good understanding of the basics of calculus, derivatives, integrals, multivariable vector calculus, and differential equations, if you have a good background of how to do those mathematical operations and what they mean, you're going to be fine. Don't let that scare you. Just the good thing about math is if you do it enough, you get good at it, right? As long as you keep going and you don't give up, right? Like I can show you, like, right now, like I have so many notes that I'm doing, right? Like, 'cause I actually kind of forgot about multivariable vector calculus. I haven't done it in a while, but now I need it, so I'm just like going back and refreshing like the concepts. And as long as you do that, you're going to be fine. So that is my analysis of the electrical engineering major. If you have any questions about it, be sure to let me know. Like, I might be able to make another video answering those questions. Yeah, thank you guys for watching this video. My name is Tim Grant, and I will see you next time.